Welcome. So in this video, we're going to look at time and date operations in pandas. So this video uses the classic model database. Um, More specifically, we're interested in the payment table simply because the payment table has a payment date field. There are other tables that have a date field, such as orders, um, and also probably those are the two tables that have a date field. So date-and-time operations are very useful in the scenarios where we're interested in asking about details or aggregates pertaining to dates. So as is, these tables have the dates encoded as strings. So if I take a look at payments, you can see that the payment date looks like a timestamp. But if you dig deeper into that data types, we will see that payment date is an object, which basically says that this is a string. So more specifically, say I want to pull this value from the data frame. So I'm going to do iloc 0, 1, and you can see that this is encoded as a string. So if I do type, I'm going to get str. So the question is asking us to report total payment by date, year, month, and year quarter. So some of these operations, as we have seen before, it's possible to do using text operations. So basically from these dates, try to pull the different components, including the year, the month, the day. Some of them will become much more cumbersome to dealing with date as string. For instance, if I'm interested in quarter, I need to write my own function to map different months to the year quarters. And this can get more complicated from this point onwards. There are so many calendar operations that pandas offer. Like for instance, if you're interested in the business day or the end of business days or the end of business months or business year, obviously you cannot do that with calendar operations. Like if you're interested in the end of the business year, this really depends on whether the 31st of December was on a weekend or not, right? So you will end up reinventing the wheel if we'll try to do this using string operations. So these operations are provided in the datetime um, um, module and associated functions in pandas. Alright, so let's take a look at these questions. All of these questions require us to convert the string to a datetime object. So pandas offer a very handy function called toDateTime. And toDateTime will take a string, it will take objects of different kinds, and it will try to convert them to a datetime object. And this function is nice because it's a universal function. It takes a single value and it can take a sequence of values, and it will still convert them to multiple datetimes instances. So let's take a look at this function before we try to apply it to our context here. So this function here, in this example, I have a text which is 6 October 2019. If I do ts is equal to pd.toDateTime text, I'm going to end up with a timestamp object. Now, timestamp object is nice because it opens up the opportunities of accessing multiple properties and functions associated with this timestamp object. So there are many of these, but what's useful here is that we can access the year, we can access the month, we can access the day, we can access the week, quarter, minutes, hour, minute, and seconds, and so on as properties, which is very handy because we can pull this information from that object immediately. All right, so let's take a look here. And I'm going to pull payment date from the payment data frame. Again, those are all string objects. So what I'm going to do, I'm going to pass this series, because it's a column, to pd.toDateTime. Once again, toDateTime is nice because it's a universal function. It can operate on a series as well as a single value. The other alternative, of course, is to apply it on all of the singular value using apply. This would have been necessary if this hasn't been a universal function, but it's not necessary here. Anyhow, those two things will result in the same outcome. So I've got myself a series here. So what I'm going to do in this series, I'm going to save it as a variable called pdate. So I'm doing this because I will need to access this series to pull the individual piece of this date timestamps, including year and months and so on. The alternative is to save it as a column in the payment data frame, which is also possible. So we can do payments pdate equals to that. So I'm going to save it as an independent series for now. Let's take a look at the questions. Report the total payments by date. Well, this question actually doesn't really require us converting to a datetime object, simply because it's just an aggregate by date. So presumably multiple payments have been done at the same date. I'm assuming it could be the case that the payments had unique dates, but we can check. If I'm curious about whether multiple payments were done in different dates, I'm going just to do unique, not unique actually, count. I'm going to get to the frequency. So let's do unique, and let's do the length here. 232, but if I do length of payment date, we have 273. So some payments have been made on same dates. Okay, so let's write the query here. I will need a group by operation to group by date, and then I'm going to pull the amount and I'm going to sum that. So I'm going to do payments group by date, sorry, payment date, and I'm going to pull the amount and I'm going to do sum, and this will give me the sum of payments in these dates. Okay, so the second one will need some pre-processing because this is asking us to report the total payment by year. So I want to pull the year field from each one of these payment dates before being able to process it. Now what I'm going to do here, we've seen how to do this using string operations. Let's do it really quickly since year is easy, right? It's the first 4 characters in each one of these text fields. So I can do payments here, payment date, and I'm going to do str to the 4th character, so 0 to 3, and this will give me the year, right? So this is the year, and then I can do payments group by this guy here, amount, sum, and this will give me the sum of payments per year. Okay, so this is a string operation. What we can do here, we can actually do something very, very similar. We can, instead of creating our series based on a string operations, we can actually pull the year from the pdate series. So here is our pdate series. How do I pull the year from this one? Well, for each one of these, for instance, P0, which is a timestamp, I can do P0.year. Okay. Now for my series, it doesn't have a year attribute here. But what I want to do, I want to apply basically this dot function on all of them. The function is simply taking each individual item and dot year on each one of these, and I get the year. So that's the series that I want to use as my group by condition. So I'm going to do this one payment.group by this guy amount sum, and I get the same result. If this thing seems a bit weird, passing a series as a group by condition, you have to remember that pandas doesn't, it will take a series as long as it has the same index as the data frame. If this seems a bit foreign to you, you can simply do something like this. You can do payments year equals to this guy here, and then of course let's peek at payment here. You can see that we've got a year field, and we can do payments.group by year, which will give us the same result. Okay. So now we managed to pull the year field from each one of these dates. Before proceeding to the remaining questions, which are very similar to this one, in essence, I'm going to show you a different way to do it. Well, now remember that pandas allows you also to index the data frame or the series using datetime object. And when we have a datetime index, we get a special kind of an index called datetime index. That special kind of index also has some extra functions, including the capacity to convert it to periods. So instead of doing this, I'm going to set the index payment.setIndex pdate. Now, as you can see here, I got myself a new data frame. Let's call it PDF for now. So what's unique about PDF compared to payments is that the index here is a datetime index. Payment had just a simple default range index. So what do I want to do with this index? So basically I want to convert it to a period. Notice that this one is a timestamp index. All these are timestamps. If I convert it to period, I can specify the periodicity of that new period index. And this basically gives me the option of saying whether I want the index to go by year, by month, by day, by hour, and so on. So if I do to period, then I think it's annual for year A. I get basically a period index because it's going per year, and I get the year corresponding to each payment here. So that's my new, that's the new group by object, the new group by condition that I can pass to group by PDF or even to payments. Probably it will work for payment, I'm not sure because this looks like a list, so we can try it. So we can do, amount sum, and we get the same result here. So it was just a way for me to get to that index, and once I get to that timestamp index, I can convert it to a period index, benefit from the fact it has such a function, and go ahead and use it as a group by condition. Now note that this function to period is not implemented for a series that contains date and time as its values. So I can't do something like to period here, that doesn't exist. Well, it does. So let's see. So see, it's giving me the errors because the index is a range index, it's not a period index. So the function exists, but it's conditional on the index being a datetime index. Okay, so The three coming questions, the four next questions are pretty easy. The three questions, we can pretty much follow the same kind of um, steps to pull year, year, month, and year, quarter. So let's do that. Let's do the month. So I'm going to basically do the same here. I'm going to create a month column here. And you can see that we've got the month here. And then I'm going to group by month, pull the amount and sum. Now, this aggregate statistics is useful if you're interested in comparing the volume of sale across the different months of the year. Obviously, this is collapsing observations from different years together. So this is January in all of the years, and this is February in all of the years. The next question is asking us to be more specific because we want to pull the year and the months at the same time. So what I'm going to do, I'm going again using the same template here to pull year and month. But I'm interested in year and month, not in month. So what should I return here? If I do year and month plus months, that doesn't work because it's going to add the year and the month together. So I will either need to return a tuple or a list because I want to keep these two things in different as two different entities, or I can format these things in a formatted string. So I can do something like this: x.year dash x.month. So then the rest is easy. It's pretty much like this one: year, month, dot sum. If I do it as a tuple, it will get me the same result, but they will be formatted slightly differently. The benefit of tuples is that those are still actual values. I can access them. In the string, I need to reparse these from a string if I need any further processing. Okay, so let's do it using that period index again. So PDF, that's our PDF dot index. That's the index to period. I'm going to specify month. I get the month. So basically I can do this payments.group by this thing, pull the amount, do the sum, same results. All right, so let's take a look at the next one. The next one is asking us for year quarter, so each quarter in every year. That's pretty easy because I have a Q here instead of M, and this will give you the quarter of each one of these years. Now again, this is where your string functions will hit their limit because there is no built-in way to figure out the quarter from the string. Let's do this using the all the other pattern. I'm going to create a new column called quarter here, and I'm going to pull x.quarter here. Okay. Oh, I need year quarter, so I'm going to do year x.quarter. All right, so and then I'm going to do payments.group by, pull my year dash quarter object, column, amount, and sum. So that should give us the same results, exactly same values here. All right, so let's take a look at the last one. The last one is the more challenging because this one is asking us to report the total payments on a bi-yearly basis, so each 6 months in each year. So there is no built-in shortcut to pull a by year, half of a year from the date. like whether the date falls in the first 6 months or the second 6 months in the year. So we need to implement this manually. Of course, we can reinvent the wheel and we can write a function that takes a look at the month, and if the month is in 1 to 6, it's going to be first the annual, and if the month is in between 7 and 12, it's going to be the second, and then we can do the group by. Okay, so let's do it just for fun. I've already pulled the month and the year. So what I'm going to do, I'm going to create a new column called by year. And this new column will be, it's not data, it's payments by year. It's going to be the following. It's going to take payments here, plus maybe a dash, plus the following. So I'm going to take payments.months. I'm going to apply this function. What's the function? I'm going to do the following. I'm going to take x, and it's simply going to be b1, well, half 1, I'm not sure what to call it. Let's call it half 1 for the sake of this example. If x in range 1 to 7, because this is exclusive, else h2. So this is a function. It takes one value. It will return h1 if this value is in range 1 to 7. Otherwise, it will be h2. Looks like we've done something wrong here. I'm not sure if this is complaining about the dash, so let's simplify it. Let's take a look at this thing here and see if it's operating as supposed to. This is working fine. And then we want to add payments.year, and this is where things are falling apart here, because the year is an integer, is not a string. Okay. So the problem here is, and I kind of did not pay attention, is that year is an integer, not a string, hence I can't do that plus a string. Okay, so I want to convert this to a string. I'm going to apply str. Alright, let's take a look at payments now. So 7 will be in h2 in half 2, and 3 will be in h1. So it looks we got this right now. So payments by year, payments.group by year. And this is what we get. We get these values. Of course, we want to pull the amount, not all of these piece of information, the amount. Alright, so that was a mouthful here. Let's try to do it in a more concise manner. What I'm going to do here, I'm going to benefit from the fact that the two-period function converting a timestamp to a period, it can operate on any period duration we wish to provide. So let's go to PDF again. That's our data frame with the index being datetime index. And of course this one, I can do period in 6 months. And this is basically giving me, trying to interpret what we have gotten here. The first observation is 2004-07. So this is not giving me what I need to do, because this is kind of just saying, just filling in these in a 6 months window. So this is not exactly what I want to do. I basically want to collapse these observations if they fit in a 6 month window. This one is basically transforming each item in this index to the period I specified here. What I want basically to do with this PDF is to resample the data frame. So if you look at PDF here, you can see that this is on a the index is going on a daily basis. I want to resample so that I take the sum of the amount in each 6 months. What I'm going to do, I'm going to resample this data frame based on 6 months. This may not work because this index is not a period index. I'm going to check if this works. It actually worked. So this is like a group by object. It's a resampler object and allows us to pull the amount and do this sum like a group by thing. So we can see here that we have in the first 6 months in 2003, we've got this this value is going on a 6 by 6 months basis, but it's ending on the beginning and the ends of these dates is not in the end of the month. This is going with a business end day instead of the business start day. I'm going to do business start instead of business end. So I'm going to do 6 months, and I'm going to start at the beginning of the month and end at the end of the month. So 6ms, and this basically gives us the same results in one shot, the one that we got with a manual processing. And this is nice because you can express any periodicity you wish. Let's say the quarter start, for instance, here, or maybe 23 hours and 3 minutes, 3M I think, was it 23 hours, and this will give you basically the results resampled at that periodicity. In 3 minutes, small m. I have to check minute t, I think, if I'm not mistaken. So you can see every 23 hours, 3 minutes we get that. So this is pretty powerful for aggregating the data on a time and temporal basis. So 6ms, and we get that result reported for us. So if your data has time and dates, those operations are very essential and very powerful. They give you much more return on your money compared to what SQL or other tools offer to manipulate the dates and times.